Alright guys, so here's that last example on that page, and we want to find the inverse of this matrix A here, and just verify that it does actually work out. So I'm going to set up a little equation to find the inverse, because we know if we're given a matrix, so I'm going to write out our matrix 8, -5, -3, 2. In order for it to have an inverse, we would be able to multiply it by the inverse, and I'm just going to put another matrix here and put in 4 variables, A, B, C, and D. So if we multiply these two matrices and they are inverses, we should get that 2 by 2 square identity 1, 0, 0, 1. Okay, so right off the bat I have this variable matrix here, and we have that 2 by 2 matrix on the other side. So we're going to take these two matrices, our original matrix A and the variable matrix, and just multiply them across using our matrix multiplication. So we're going to get a 2 by 2 matrix with a bunch of variables in it. So to start off, right, our first row, that first entry is going to be 8A minus 5C. First row by the first column. First row, second column, 8B minus 5D. Alright, and moving on to the second row, first column, -3A plus 2C. And our last entry here, -3B plus 2D. So I have this 2 by 2 matrix equals the identity on the other side. And then hopefully you guys are seeing where we're going here, right? We have 4 entries, and our identity matrix has 4 entries, so I have 4 equations, each with a solution. So I'm just going to rewrite them out equal to the corresponding entry. So we'd have 8A minus 5C equals 1, -3A plus 2C equals 0, 8B minus 5D equals 0, -3B plus 2D equals 1. Alright, so if I was in the classroom with you guys right now, I'd stop and say, okay, what do we do now? We've got a bunch of equations, we've got a bunch of variables, but we need to know what the 4 variables are. And everybody would be sitting there with their hands up in the air, so excited to answer this question. And you give me answers like, oh, we could solve using substitution, right? We could solve for A and then put that in the other equations. Or we can solve using elimination, right? Just solving these two systems, because we have the system on the left, right, for A and C, and the system on the right for B and D. And I'd say, yeah, sure, those are all things we've done before. Anybody have another idea? And somebody would remember from last chapter, we solve systems using matrices. So we're going to rewrite these systems using matrices. So we'll have our coefficients, right? This would be an augmented matrix with that 1, 0 on the other side. And same thing over here. Now, check out these two matrices, right? What do we notice? The left side is exactly the same. Our coefficient matrix is the same. So something kind of nice about matrices, if this is true, we can make what we call a doubly augmented matrix. So I'm going to take both of these coefficient matrices and augment them with our identity matrix, or both of these solution sets. So I'm going to write a big matrix down here. I have that 8, -5, -3, 2, and then on the right side, 1, 0, 0, 1. So in the future, when we're looking for inverses, we're going to skip right to this step. That's just our original matrix A, right up top, augmented with the identity matrix. So our goal now, if we're using the calculator, we would tell it to put it in reduced row echelon form, and then we would have our inverse matrix. We're going to try one time, you guys can run through with me now in the video, to use that Gaussian elimination, like we're solving systems of equations, to get the identity matrix here. So to change this to reduced row echelon form. Alright, so kind of follow along what I'm doing here. My first goal is going to be to get my zeros in this matrix. So I'm going to right now try to get this -3 to be a 0. So just like if we were doing elimination with a system of equations. So I'm going to do 3 row 1 plus 8 times row 2. And I'll write out my answer here. So I didn't change row 1. I'm just changing the second row. So we get that 0 that we need. 3 times 8 is 24. 8 times -3 is -24. Those cancel. For that second entry, we'd have 3 times -5, which is -15, plus 8 times 2 plus 16, so that gives us a 1. Really nice, because that's what we need for our identity. And don't forget to do the other side. So 3 times 1 plus 8 times 0, that gives us 3. 3 times 0 plus 8 times 1, that gives us 8. Alright, so far so good. Our next step, I'm going to go for that next 0. So this position over here, this -5, we want that to be a 0. A little bit simpler this time because we can use the 1 in the row underneath it. So I'm going to do 5 row 2 plus row 1 to eliminate that -5. So once I do that, right, my 8's not going to change because it's a 0 below it. If I do 5 row 2, that's 5 plus -5. That gives me the 0 we need. I'm going to write in the second row, that doesn't change. So we do 5 row 2, 15, plus 1 is 16. 5 row 2 over here, that's 40, plus 0, that's our 40 in that last position. Alright, so one last step to get our identity matrix over here. Hopefully you're speeding ahead of me because it's so obvious, right? We're just taking that first row and factoring out the common factor of 8. Trying to grab the right pen color, there we go. So I'm going to have my identity matrix on the left, 1, 0, 0, 1. And on the right, I will have a 2. If I divided it by 8, a 5, a 3, and an 8. Alright, so that would be the matrix that we needed from the beginning. And remember what we were looking for. We were looking for the inverse of the original given matrix, A inverse. So I am left with, at the end, A inverse equals 2, 5, 3, 8. Alright, and we're set. Alright guys, so once you get there, you definitely want to check your answer, and by hand we can just take our inverse matrix that we got and multiply it by the original matrix A, and we should get that identity matrix. You can also check it on the calculator 2 ways, right? Put A in and your A inverse in, multiply them. You can put in this original matrix over here and change it to reduced row echelon form. You should get our matrix over here that we got. Also, another really simple way to get an inverse matrix on your calculator, now that we know how they determine how to get a matrix in general. I'm going to erase some info I have here so we've got room. So in your calculator, if you wanted to get the inverse of this matrix A, you would just input our matrix, 8, -5, -3, 2, and that matrix button that you normally hit, the normal button for it looks like an x to the -1st, right? So if you put in that matrix and raise to the -1st power, it will give you the inverse matrix that we got. Alright, so there may be times where I ask you to do this by hand if you don't have a calculator, but we're going to figure out some nice, easy ways to kind of find the inverse of a 2 by 2 and so on and so forth. So you guys can flip to the next page. I'm going to bring it up here for us. looks like this, and you can find the inverse a couple ways. I want you to try out A, right? Maybe do one more with that kind of Gaussian elimination method. Definitely check it by multiplying or check with your calculator. And then for number 6, just use your calculator to find the inverse. So you can put in that augmented matrix, or you can just use the inverse button. Alright, so pause this video, try it out, and then play it when you want to see what the answers are. I'm going to write them out for us right now. Alright guys, so here's our 2 answers. For number 5, either if you did it by hand or if you did it in your calculator, if you just hit the A inverse button, we would have seen that your calculator probably said singular, meaning it doesn't have an inverse. If you used our Gaussian elimination method like I showed here, then your reduced row echelon form would not have the identity matrix on the left side. So that means, right, if we can't get the identity, it's a singular matrix. It doesn't have an inverse. So I'm going to write for our answer for that. That would be singular. All right, then number 6 there, just put A into your calculator. Use your inverse button, and you should have come out with this 3x3 inverse. All right, so kind of lengthy video for this inverse portion of 6.2. I left a spot for you guys to summarize how you can find the inverse of a n by n square matrix. I'll also be posting up the notes online in the next few days, so you can write down what I have if you'd like, but just summarize a couple ways to figure out the inverse matrix. And for number 3, I just had you split it up if it is invertible, and then make a little note if something is not invertible, right, if it's singular, how we would know that by looking at the calculator or by looking at our reduced row echelon form. Alright, so try out those problems, and the next video will be on the last portion of our notes you guys will be responsible for, which is our 2x2 inverses and determinants.
Bye!